Welcome to the Arduino Development for Beginners course. I'm Altbeer and I will walk you through this course that's been updated for the BSidesDFW 2020 Hardware Hacking Village. This slide deck is available at altbeer.us/Arduino. So what is an Arduino? An Arduino is a tool that allows computers to sense and control more of the physical world than your desktop computer can or laptop computer can. It's called a development platform because you can wire up sensors and other devices in the physical world and then use the computer via code to control or read from those devices. It can be used to work with interactive objects like switches or sensors, control lights, motors, and other things. You can create robots that are controlled by these platforms. There's a lot of uses for them. And given all the use cases for them, there are a lot of different types of Arduinos. There's many different boards and they have different layouts and different use cases that they were built for. And we'll go through a few of the more common ones. So the Arduino Uno is probably the most common Arduino out there. It is using an ATmega 328P processor, which has 32K of flash and 2K of RAM. It has 14 digital pins and 6 analog pins. Now, the Arduino Nano is another version of Arduino that is very commonly used. It has the same type of processor as the Uno, but it has about half of the flash and half of the RAM. It has the same exact number of I/O pins, though, as far as digital, and I think it has a couple more analog pins than the Uno. But basically, they're different form factors. So the Uno is about twice the size of the Nano, but these are two commonly used boards. And then you have the Mega is another one that's used quite a bit. The Mega has a ton of digital pins, like 54 of them and 18 analog pins. So if you're doing a whole lot in a project with a single board, this is the board you would go with. It has a lot more flash and RAM than the other two, about 4 times the amount of RAM than the Uno. There is an Ethernet Arduino that is very similar to the Uno, but it has an onboard Ethernet adapter so that you can connect it to a network to do network-based applications or control it via the network. The LilyPad Arduinos are wearable electronics, and they're designed to work with conductive thread that can be sewn into wearable projects and conduct electricity to wearable components. And then the FiO is another small form factor one. It has about the same specs as an Uno, but it's in a much smaller form factor. And those are just some of the boards that are available. So how do we control the Arduino and tell it what to do? Well, Arduino has its own scripting language. You could push C code firmware to it, but it has its own scripting language that you can use with the base firmware that's on it. And the Arduino IDE software is a good place to start when working with an Arduino as far as getting code onto it using this scripting language. IDE is Integrated Development Environment. So this is a piece of software that you would download and use on your desktop or laptop to interface with an Arduino that's connected to your system via a USB port. So this would this software allows you to write a piece of code and upload it to the Arduino to execute that code. And where do you get this software? This software is provided free of charge by Arduino.cc. That is the official website for Arduino things. If you click on software and then downloads, you'll be presented with a number of options based on your operating system. There are versions that support Windows and Linux as well as Mac OS, and you can also compile it from source code. They give you the source code there. It's an open source project. Now, the first time that you work with your Arduino IDE software, you're going to want to set it up for whatever Arduino board you're using. And obviously, if you use different boards, you'll have to change it when you interface with different boards. So under the Tools section, you have a selection for the board type. And you can see on the graphic here, the drop-down has a lot of different options. In this case, I'm choosing the NANO. You can also choose the processor type, and this is because some of the Arduino models come with different processors. The NANO is a good example. It had 2 different processors that it worked with, and as far as the 328P processor, that's the newer processor, it actually had an old style bootloader and then a newer style bootloader, and so you have to select which you're using, if it's the newer style or the old bootloader. And in the case of the BSides Hardware Hacking Village, this is an important note. Those Arduinos that were sent as part of the Hacking Village kits will require the old bootloader. And then the port can be set as well. This is a COM port, so when you plug the Arduino in via a USB connector, it's going to assign it to a COM port on your machine. That's just a communication port. And it should auto-detect this fine, but if for some reason it's not auto-detecting it, you'll have to look up what COM port is assigned to that in your USB settings. And then once you know what that COM port is, you can manually set the port on the IDE software. But that shouldn't be necessary in most cases. And at this point, once you have the board all set up, you're free to program and upload code to your Arduino. The IDE software comes with a whole lot of examples as well. There are examples to do a lot of different things. So if you're looking for how to do something, how to read from a sensor or control a motor or do basic communications, there are example programs for all of those things, and you can easily just load the example program and then modify it for your use. That is a very easy way to quickly get up to speed on how to use the Arduino language. So the next few slides, I'm going to provide a basic overview of electronics that I believe is the bare minimum that you're going to need to know to work with the Arduino and the projects that are presented here. There's a more detailed electronics overview available at altbeer.us/electronics. And these are just a few of the slides taken from that larger slide deck. So the first thing we'll talk about is current types. There are 2 types of electric current, alternating current, AC, and direct current, DC. In AC, the direction electricity flows through the circuit is constantly reversing. The frequency of the rate of that reversal is measured in hertz. And so when you say like the US power supply is 60 hertz, that means it reverses 120 times per second, two times per cycle. In DC electric, electricity flows in one direction between power and ground. And in this arrangement, there's always a positive source of voltage and a ground source of voltage. That's 0 volts. Generally, most modern electronic devices use DC, direct current. And the reason that they use that is because DC more easily can deal with binary and logic states. Now, AC power is probably what you're used to using throughout your house to plug things in, but most of the electronics are converted to DC. So if you plug in a laptop power cord into the wall power that you're plugging into is AC power. But that square brick that is leading to the laptop, that square brick is a transformer that's turning AC power into DC power, so that when you plug that small wire into your laptop, you're actually providing DC power to your laptop because it runs off of DC. And many electronics do that. You'll have converters to convert from AC to DC so that the electronics use DC power. Now let's talk about open and closed circuits. Electrons will not flow through an open circuit, but they will flow freely through a closed circuit. So on the left we have a picture of an open circuit, and you can see the light bulb was turned off. And on the right we have a closed circuit, and you see the light bulb's on. And a switch is a device that allows a circuit to be toggled between either open or closed states. So think of a light switch in your house, right? When the switch is in the off position and the lights are off, it is an open circuit. It's not allowing power to flow through that light bulb. But when you flip the switch into its on position, it closes the circuit, allowing the electricity to flow through the light bulb, the load device that's drawing electric load. And now we'll talk about parallel versus series circuits. In a series circuit, the current through each of the components is the same. And the voltage across the circuit is the sum of the voltages of each component. That's a big sentence. What it means is this. The components in this diagram on the left, being two light bulbs, the components are wired through each other. So it's one contiguous circuit where you go from one light bulb to the next light bulb. Now, in the case of this diagram, we have a 1.5 volt battery. So if I'm sending 1.5 volts from the negative side of this battery over to this first light bulb, and that first light bulb, let's say it drops the voltage by half a volt by producing light, it's going to drop that voltage a little bit. Let's say it drops at half a volt. That means that the next light bulb in line is only going to have 1 volt applied to it, and then it will return. And so there's voltage drops that happen through different component types, and that can affect things in a series circuit because things further on in the circuit get lesser voltage then. But the current remains constant through the circuit, so it's one contiguous circuit. Now a parallel circuit, the voltage across each of the components is the same, and the total current is the sum of the currents between the two. So in this case, imagine it's two independent circuits that happen to be interconnected. So what that means about current being the sum is that both light bulbs are going to draw a certain amount of current, and that total amount is the current draw of this parallel circuit. But in our battery case, where we have 1.5 volts available, each light bulb is going to get 1.5 volts applied to it as it passes through this circuit. And it's a big distinction because series versus parallel makes a big difference to components that are sensitive to voltage or current, and you have to make the right choice based on the component that you're working with. All right, we're going to talk about resistors. So a resistor is a passive component that implements a resistance to current on a circuit. It can also act to lower voltage levels within circuits, but its primary use is to reduce the current flow. So the amount of resistance that a resistor adds is measured in a unit called ohms. And the ohms measurement, the higher the amount of ohms, the higher the resistance. Resistors are nonpolar components, meaning that they can be placed in a circuit in either direction. It doesn't matter which way you plug it in. It's going to perform the same either way. As far as the value of the resistance, that is printed on resistors in the form of colored stripes. There's two different color codes that are used. They're both very similar and both use the same color code table. One uses 4 stripes and one uses 5 stripes. And you can use a table like this one to determine the value of a resistor simply by looking at the color codes printed on the resistor. So a photoresistor is also known as a light-dependent resistor, or LDR. It's a passive component that also affects current flow. It imparts resistance to current flow just like a normal resistor. But a photoresistor, its resistance amount depends upon the intensity of light that is placed upon it. So under dark resistance, or under dark conditions, it's going to have very high resistance, like 1,000,000 ohms or more. Under bright conditions, the resistance is going to be lowered, maybe down to about 1 to 200 ohms. Now, photoresistors, just like normal resistors, are non-polar components, meaning they can be placed in either direction in the circuit, and they work the same way. And a photoresistor can be applied in any kind of a light-sensitive detector circuit or a light activation circuit. So you can use it to turn on an LED or turn off an LED based on the conditions of light in the environment. Diodes and light-emitting diodes, and I call those out separately because not all diodes are light emitting. Light emitting diodes, LEDs, are one type of diode. Probably the most common type, but one type. So a diode is a component that primarily conducts electricity or current flow in one direction, meaning that it has very low or zero resistance to current in one direction and very high or infinite resistance in the other direction. This directionality means that diodes are polar components. They have polarity. So that means they must be placed in a circuit in the proper direction. Now, the two electrodes on a diode are called anode and cathode. These are the legs or pins that come off a diode. Those are electrodes. The anode is the positively charged electrode, and the cathode is the negatively charged electrode. The anode, being positively charged, should be placed in a circuit towards the positive source of power, and the cathode towards the negative source of power, or ground. So a light-emitting diode is a special type of diode that emits light when it's activated. So when a suitable voltage is applied to it, electrons that pass through the LED release energy in the form of photons. And that effect is called electroluminescence. And the color of light that corresponds to the energy of the photons released. So basically, the LED can be made in such a way that it passes certain photons of light, producing a certain color. Now, some LEDs will only produce white light, and they make it a colorful LED by coloring the plastic housing around it. But LEDs that have clear housings but are showing like red or green light, that is done by them making the LED in such a way that only those photons of light are passed. So this next section, we're going to get into the Arduino projects. So these next two projects I'm going to go into are staples in Introduction to Arduino. They've been presented many times by many others and are well documented on the internet because they're so effective at showing how to use the Arduino. But they're very simplistic. and I wanted to expand upon how I use those circuits. So I'm going to present them once here in the simple way that they're normally presented, and then I'm going to go ahead and present them again along with other more advanced code in the intermediate code section or project section that's going to follow this. So you can feel free to skip ahead to that section if you want to build these same circuits and use them in several different ways. But we'll step through them simply here first. So this first example is to make an LED blink. You can use an Arduino Nano or an Uno, which I'll show on the next slide, an LED and a resistor, and then some jumper wires. And you're just going to wire it up between a digital pin, I think we use pin 13 in this example, and ground, and then wire the circuit in this manner. We can do it the same way with the Uno. The Uno has the same digital pin number that we can use. So it doesn't make much difference in which case, and the code would be the same to control this on either an Uno or a Nano. And what we're going to do with this code is fairly simplistic. We're going to first set up a global variable that's an integer called LED, and we're going to set that to the number 13, which represents the digital pin number. We're then going to run a setup function that is going to initialize that pin. So we're going to tell it the pin mode for LED, that's the digital pin 13, is an output pin. So we're going to send signals out. We're not going to read in. And then we're going to create a main loop. And in that main loop, we're going to do a digital write function to write to that LED pin. And high on a digital write is a 1. This is on. So we're going to turn the LED on, and we're going to hold it there with a delay statement for a second. And then we're going to digital write low, which is 0, which will turn the LED off. And then we'll hold it there for a second. And it's going to continue through this loop indefinitely. This is the main loop. And there's nothing to break it out of that. So it's just going to blink the LED on and off in 1 second intervals. Now this code is available on in the same directory as this presentation. You can get to it on the link here. Or I believe this code is the same exact code that is in the examples in the Arduino IDE. So you can go to File, Examples, Basic, Blink, and you'll have this same code. So the next project, we're going to look at making a red, green, blue LED blink. Now red, green, blue LED, it's like 3 LEDs built in one housing. And in this case, we're using a common cathode RGB LED, which means that the 3 LEDs are all sharing a single cathode. So that way, it's instead of having 6 pins like you would for 3 LEDs, you only have 4 pins. And here's a diagram of it on the right where you show the LEDs are all sharing a single ground or cathode pin. So what we're going to do here, and this can be done on an Uno or a Nano, but we're going to wire up the resistors to 3 of the digital pins, and then the cathode, we're going to bring it to ground, and then connect those resistors to the 3 different anodes for the 3 colors. Now, I should note that in this example, digital pins 3, 5, and 6, whether you're on the Uno or the Nano, those are what's called pulse width modulation, or PWM pins, which means we can use analog write functions on these pins. And instead of just a 0 or a 1, we can actually use the numbers 0 to 255 for off to on, and all the light intensities between those numbers. And that's what we're going to do in this example. So we're going to define our red, green, and blue pins, define them as output pins. We're going to set some initial integer variables for red, green, and blue values. We're going to set up a color loop. So it's going to loop 3 times for the 3 different colors, red, green, and blue. And then for each of those loops, we're going to fade a color from one to the next. And so that's where we're setting the color between 0 and 255. We're going to use analog writes because we're using colors that are not binary. It's a byte or an analog write. We'll use a full byte anywhere from 0 to 255. So because of that, we're using an analog write. And this would only work on a digital pin that supported PWM. So that's important to note because later on in the examples that I do in the intermediate projects, we're going to use digital writes instead for this same type of function. And then we, when the fade is complete, we set it to a single color for a second, and then it continues. So this code is also available as a text file where this presentation is. And I believe that there's an example in the Arduino IDE for red, green, blue LEDs as well. And now we get to the intermediate projects. I'm not going to go into a huge amount of detail in this presentation on each one of these pieces of code because I'm doing separate videos for each of these called Lab 1, Lab 2, and Lab 3. And these are the 3 different labs that I'll walk through in those videos. So if you're interested in more details about each of these, please view the lab video corresponding with each of these. But I will give a quick overview of what we're going to do in each of these real quick now. So the first example is we're going to build a circuit with a single LED. And in this case, we're going to make sure that that LED is on a PWM pin. And once we build that circuit, we're going to run a couple different pieces of code through it. So our first piece of code is going to be much like the blink code that we used in the previous example. We're using digital writes to just turn the LED on and off. One thing of note is that in my code, I tend to use the hashtag define for global variables that are constants that I'm defining, rather than just set an integer for that. Because it is a constant that's not going to change, define clearly outlines that, and it's just a habit that I use, but both would work in this code. So then the next piece of code that we would use is using analog writes to that LED that is going to fade the LED on and off between 0 to 55. And we have the code to do that. And then in addition, in this code, I'm using serial writes or serial prints to send serial signals out. And you can use the Arduino IDE's serial monitor function to actually see the information that I'm printing out. So in this case, you would see the LED values getting set and what the value is in real time as it's setting that for the LED. And then the last piece of code is very similar to the previous in that it's using analog writes, but instead of stepping through every single value from 0 to 255 and back, I am defining an array and using that array to predefine values and then read that array to analog write to the LED so that it will step through the array elements. And then we use the serial monitor again in this example. So then lab 2 will go into our red, green, blue LED. And in this example, in addition to the LED, I'm wiring in a tactile switch, which is a push button basically. And we're going to read in on a digital pin the results of this tactile switch, whether it's pushed or not, and use that to control whether the color changes. So here's our circuit, and it's very simple circuit and similar to the example on the right, where we're just hooking up 3 resistors and an RGB LED. But then on the left, we have our actual button and its components. And as far as the code, the first piece of code that we use is a simple color cycle, similar to the simple project. We're defining our pins. We are going to use a serial monitor. And then in the loop, what I do is I set up an array for the different colors. And so what I have is 7 different colors that I want to set that RGB LED to. And then I have the corresponding red, green, and blue numbers representing whether red, green, or blue need to be on or off in order to represent that color on the LED. And then I walk through the for loop 3 times to set the red, green, and blue color based on our current color mode. And then I increment that color mode to where I go from 0 white to 1 red to 2 yellow each time I go through the main loop. And then the next piece of code expands on that. So it's the same basic code to set up the LED. And we set up our array. And then we have our switch state. So we do have the switch pin is being defined as an input pin. And then here we're going to do a digital read of that switch's state into a variable. And then based on if the switch state is high, meaning the button is pushed, that is when I will increment the color code. And if that button is not pushed, every time it runs through this loop, it will present the same color until the button is pushed. And then it will proceed to the next color in the array. All right, and our last lab 3 talks about controlling an LED with a photoresistor. So here we have the circuit where we have an LED hooked up with a resistor, a regular resistor on a circuit on the Arduino. But then we also have a photoresistor that's connected between the 3.3 volt power and the analog 0 port. We use a pull-down resistor to make sure the analog 0 port is always in a low state unless the signal from the resistor pulls it high. And here's an example of the circuit that is being built. So on the right side here we have the LED, and then on the left side we have our photoresistor and its pull-down resistor. And here's a piece of code that will implement this. And we do use serial monitor with this code as well, so you can see what's going on. So we're going to define the LED and photoresistor pins. Then we're going to set the pin mode for the LED as output, the pin mode for the photoresistor as input. We're going to set a variable in the main loop, that's our threshold. And then we're going to read in the value that the photoresistor is sending the analog pin. We're then going to see, is the value greater than our threshold? If it is, we're going to turn that LED off. And if it's not, then we're going to turn the LED on. And then we put a delay in there and loop through that. And with this code, you'll be able to cover up the photoresistor to produce dark with your finger, and it will light the LED. And when you lift your finger and it sees light in the room, it will turn the LED off. And then this last piece of code is just an expansion on the previous code, where we're still going to light or not the LED based on light. But instead of just looking in the serial monitor at the values that it's seeing on the analog pin as raw values, we want to convert those values to actual luminosity values, which are measured in a unit called lumens. And so I have a piece of math here that's been added that will do that conversion. So if it gets fed in the raw value, it will return what the lumens value is. I didn't write this math, but I know it works. I stole it from another site, and I incorporated it into this design. So don't ask me to explain this math, but I do know it works and it produces the right values. And so when we run through the circuit, we can see that when we do our analog read, now we're going to set a new variable called lux, and we're going to set it equal to this variable that we're going to give it the value that we're getting from the analog pin. And what that's going to do, it's going to run through this math, and it's going to return the lumens value, which will go into our lux variable. And then the lux variable is our lumens, and we print that out to the serial monitor. Everything else in this code works the same as the previous example. The only difference is in the serial monitor, we're now printing the lumens value. And that is it for this presentation. I hope you enjoyed it, and I hope you learned something from it. This slide deck is available at altbeer.us/Arduino. The code will be available on my GitHub site, which will be linked. And the videos for labs 1, 2, and 3 will also be linked below here, so you can look into greater detail into those lab projects that I just quickly ran through here. Thank you so much for attending.